The MIT Energy Initiative presents MIT spinoff Takachar processes waste biomass to reduce airborne emissions. Written by Catherine M. O'Neill. To prepare fields for planting, farmers the world over often burn corn stalks, rice husks, hay, straw, and other waste left behind from the previous harvest. In many places, the practice creates huge seasonal clouds of smog, contributing to air pollution that kills 7 million people globally a year, according to the World Health Organization. Annually, $120 billion worth of crop and forest residues are burned in the open worldwide, a major waste of resources in an energy-starved world, says Kevin Kung, SM13, PhD 17. Kung is working to transform this waste biomass into marketable products and capitalize on a $1 billion global market through his MIT spin-off company, Takachar. Founded in 2015, Takachar develops small-scale, low-cost, portable equipment to convert waste biomass into solid fuel using a variety of thermochemical treatments, including one known as oxygen-lean torrefaction. The technology emerged from Kung's PhD project in the lab of Ahmed Ghoniam, the Ronald C. Crane, 1972, professor of mechanical engineering. Biomass fuels, including wood, peat, and animal dung, are a major source of carbon emissions, but billions of people rely on such fuels for cooking, heating, and other household needs. Currently, burning biomass generates 10% of the primary energy used worldwide, and the process is used largely in rural, energy-poor communities. We're not going to change that overnight. There are places with no other sources of energy, Ghoniam says. What Takachar's technology provides is a way to use biomass more cleanly and efficiently by concentrating the fuel and eliminating contaminants such as moisture and dirt, thus creating a clean-burning fuel, one that generates less smoke. In rural communities where biomass is used extensively as a primary energy source, torrefaction will address air pollution head-on, Ghoniam says. Thermochemical treatment densifies biomass at elevated temperatures, converting plant materials that are typically loose, wet, and bulky into compact charcoal. Centralized processing plants exist, but collection and transportation present major barriers to utilization, Kung says. Takachar's solution moves processing into the field. To date, Takachar has worked with about 5,500 farmers to process 9,000 metric tons of crops. Takachar estimates this technology has the potential to reduce carbon dioxide equivalent emissions by gigatons per year at scale. Carbon dioxide equivalent is a measure used to gauge global warming potential. In recognition, in 2021, Takachar won the first ever Earthshot Prize in the Clean Air category, a £1 million prize funded by Prince William and Princess Kate's Royal Foundation. Roots in Kenya. As Kung tells the story, Takachar emerged from a class project that took him to Kenya, which explains the company's name, a combination of takataka, which means trash in Swahili, and char for the charcoal end product. It was 2011, and Kung was at MIT as a biological engineering grad student focused on cancer research. But MIT gives students big latitude for exploration, and I took courses outside my department, he says. In spring 2011, he signed up for a class known as 15.966 Global Health Delivery Lab in the MIT Sloan School of Management. The class brought Kung to Kenya to work with a non-governmental organization in Nairobi's Kibera, the largest urban slum in Africa. We interviewed slum households for their views on health, and that's when I noticed the charcoal problem, Kung says. The problem, as Kung describes it, was that charcoal was everywhere in Kibera, piled up outside, traded by the road, and used as the primary fuel even indoors. Its creation contributed to deforestation, and its smoke presented a serious health hazard. Eager to address this challenge, Kung secured fellowship support from the MIT International Development Initiative and the Priscilla King Gray Public Service Center to conduct more research in Kenya. In 2012, he formed Takachar as a team and received seed money from the MIT Ideas Global Challenge, MIT Legatum Center, and D-Lab to produce charcoal from household organic waste. This work also led to a fertilizer company, Safi Organics, that Kung founded in 2016 with the help of MIT Ideas, but that is another story. Meanwhile, Kung had another top priority, finding a topic for his PhD dissertation. Back at MIT, he met Alexander Slocum, the Walter M. May and A. Hazel May Professor of Mechanical Engineering, who when a long walk and talk along the Charles River suggested he turn his Kenya work into a thesis. Slocum connected him with Robert Stoner, Deputy Director for Science and Technology at the MIT Energy Initiative, MITI, and founding director of MITI's Tata Center for Technology and Design. Stoner in turn introduced Kung to Goniam, who became his PhD advisor, while Slocum and Stoner joined his doctoral committee. Roots in MIT Lab. Goniam's telling of the Takachar story begins, not surprisingly, in the lab. Back in 2010, he had a master's student interested in renewable energy, and he suggested the student investigate biomass. That student, Richard Bates 10 SM12 PhD 16, began exploring the science of converting biomass to more clean-burning charcoal through torrefaction. Most torrefaction, also known as low-temperature pyrolysis, systems use external heating sources. But the lab's goal, Goniam explains, was to develop an efficient, self-sustained reactor that would generate fewer emissions. We needed to understand the chemistry and physics of the process and develop fundamental scaling models before going to the lab to build the device, he says. By the time Kung joined the lab in 2013, Goniam was working with the Tata Center to identify technologies suitable for developing countries and largely based on renewable energy. Kung was able to secure a Tata Fellowship and, building on Bates's research, developed the small-scale, practical device for biomass thermochemical conversion in the field that launched Takachar. This device, which was patented by MIT with inventors Kung, Goniam, Stoner, MIT research scientists Santosh Shambhao, and Slocum, is self-contained and scalable. It burns a little of the biomass to generate heat. This heat bakes the rest of the biomass, releasing gases. The system then introduces air to enable these gases to combust, which burns off the volatiles and generates more heat, keeping the thermochemical reaction going. The trick is how to introduce the right amount of air at the right location to sustain the process, Goniam explains. If you put in more air, that will burn the biomass. If you put in less, there won't be enough heat to produce the charcoal. That will stop the reaction. About 10% of the biomass is used as fuel to support the reaction, Kung says, adding that 90% is densified into a form that's easier to handle and utilize. He notes that the research received financial support from the Abdul Latif Jameel Water and Food Systems Lab and the Deshpande Center for Technological Innovation, both at MIT. Sunil Thengane, another postdoc in Goniam's lab, participated in the effort to scale up the technology at the MIT Bates Lab, no relation to Richard Bates. The charcoal produced is more valuable per ton and easier to transport and sell than biomass, reducing transportation costs by 2/3 and giving farmers an additional income opportunity, and an incentive not to burn agricultural waste, Kung says. There's more income for farmers, and you get better air quality. Roots in India. When Kung became a Tata Fellow, he joined a program founded to take on the biggest challenges of the developing world with a focus on India. According to Stoner, Tata Fellows, including Kung, typically visit India twice a year and spend 6 to 8 weeks meeting stakeholders in industry, the government, and in communities to gain perspective on their areas of study. A unique part of Tata is that you're considering the ecosystem as a whole, says Kung, who interviewed hundreds of smallholder farmers, met with truck drivers, and visited existing biomass processing plants during his Tata trips to India. Along the way, he also connected with Indian engineer Vidyant Mohan, who became Takachar's co-founder. It was very important for Kevin to be there walking about, experimenting, and interviewing farmers, Stoner says. He learned about the lives of farmers. These experiences helped instill in Kung an appreciation for small farmers that still drives him today as Takachar rolls out its first pilot programs, tinkers with the technology, grows his team, now up to 10, and endeavors to build a revenue stream. So, while Takachar has gotten a lot of attention and accolades, from the Ideas Award to the Earthshot Prize, Kung says what motivates him is the prospect of improving people's lives. The dream, he says, is to empower communities to help both the planet and themselves. We're excited about the environmental justice perspective, he says. Our work brings production and carbon removal or avoidance to rural communities, providing them with a way to convert waste, make money, and reduce air pollution.